Hello, Math 1332 students. So I've had a couple of questions about how exactly you get the calculator, the graphing calculator, to help you solve an equation like this, which is compound interest, for a variable other than a, right? I mean, if it's a you're solving for, you just plug in the p and calculate away. But how do you solve it for, say, in this example, where the question was, what principal will increase to $1 million over 5 years when the best APR available is R equal to 3.04% and you're compounding monthly? Okay, so what's going on there is that we are given the information that A is equal to 1 million, R is equal to 0.0304, T is equal to 5, N is equal to 12, and our question is, what is P? Okay. So if we plug those known values back into this equation, we get something that looks like 1 million. I'm just going to write it as 10 to the 6 just to fit it in here. There's 10 to the 6 is equal to P, that's our unknown. Let's start putting in those operations because we're using the graphing calculator, times 1 plus 0.0304 divided by 12, because they said compounding monthly, and raised to the, let's see, that's 12 times 5, right? So now we have an equation with all known values except for P. How do you solve that exactly using the graphing calculator? All right, so in general, to solve an equation, A equal to B, using the graphing calculator, here's what you do. You set y1, which is in y equals, right? Set y1 equal to the left-hand side, A, set y2 equal to the right-hand side, B, have one variable floating around. Then you graph both y1 and y2 so that you see them cross in the graph. And then you use a special feature called intersection or intersect in the graphing calculator to get it. All right, so in other words, here we're trying to solve this one. 1 million is equal to P times 1 plus 0.034 divided by 12, all that in parentheses raised to the 12 times 5. A little tip here, if you did multiply out that 12 times 5 and just write 60 there, your graphing calculator will work a lot faster. But you could literally do that. You could enter y1. Now let's see, can I get this so that you guys can read that? I'm hoping I can. You set y1 equal to 1 million. Trying my best here. Okay, y1 equal to 1 million. Let's see if I turn it this way. Ooh, yeah, that's better. So y1 is equal to 1 million. I've set y2 equal to, now, look what I'm trying to put in here. I'm trying to put P times all that, right? There's no P variable in here. There's only the X variable. So I have to write down for myself that I'm letting X in the graphing calculator be our P. So X is equal to P. And so instead of P there, I'm replacing with X here, right? And so that's what I've got here under y2, hoping you can read that. Okay, and so now I press graph, which is right over here. And if I have, if I'm really super lucky or I've fixed the window enough, well, I'm going to talk about that in a second, I'm going to see where those two curves intersect. You see that? You see those two lines intersecting, all right? So once you have that picture where you see the two curves, y1 and y2 intersecting, then how do you get the calculator to tell you the coordinates of that intersection point? Well, that's where you use a feature called calc. It's written in blue there, so you need to press second function, calc, right? Now it gives you a list of possible features. We're going to be using a lot of these this semester. One of them is intersect. It's about the fifth one down. So you can just type in the number 5 or just go down there and highlight intersect. Then you press enter and it asks you some questions. It says, is the first curve, and then it writes an equation. So is the first curve, so it says first curve, question mark, and then at the top it says y1 equal to 1,000,000, and you say yes by pressing enter. Then it says, is the second curve, and up at the top it's saying y2, the equation for y2, and you say yes by pressing enter. The whole reason for all that is that if you had like 10 curves typed in, y1, 2, y1, y2, y3, y4, 10 different formulas, you might want to know which two you want to find the intersection between some particular two. So that's why it has that feature. And then it asks you, would you like to guess? This is a lovely hangover for the days when this was an educational tool. And so, and also for other reasons, but we're just going to, if you don't just want to pass by the guess, you just press enter again, and it gives you an intersection point. It says intersection, and then it gives you X and Y. So let's look at the results that I've already written down here. So underneath the graph, now it says intersection. It's saying X is equal to 859,153.4, Y equal to 1,000,000. Now that's not surprising that Y is equal to 1,000,000, because that is the horizontal line where Y is always equal to 1,000,000, right? That's why we chose it to be Y1. Okay, we're trying to see when this other expression, the other side of the equation, the B side, when does that expression equal the A side, equal to that constant? And it's telling us the answer right here. It's saying it happens when X is equal to 859,153.4. Okay, you might be kind of lost, like, what is that supposed to mean? Go back to the substitution. You did a substitution where you let X equal to P. So this X is really the P. So here's the answer. When the principal that you've put in, you can grow to $1 million in only 5 years with an APR of 3.04% if the principal that you invest is $859,153.40. Meh. So, of course, there's no such thing as a free lunch, right? But that's how an example of how you can use the graphing calculator to solve an equation involving one of these formulas like compound interest, right? When you're not just finding A, you're solving for one of the other variables. Let X be that other variable, type in all the other known values, set Y1 equal to one side, set Y2 equal to the other side, and use second function calc intersect. Okay.